We are doing number 45 from chapter 4, section 1. I'm just going to re-explain the notes I've already done here. So we're asked to find the maximum and minimum values. And how does that happen? You need to know they occur only at critical points and endpoints because we have a continuous function. That's a continuous polynomial. That's a continuous trig function. So we know f of x is continuous. So we need to find the critical points. Well, let's take the derivative, and this is the tricky part. That power rule, 2 comes in front, decrease that by 1, 2x. This, you just have to know the derivative of an inverse cosine. Now the tricky part comes. One way to do this is get a common denominator, and I'll show you another way also. So to get a common denominator, I need that over here. So I multiply by 1, that gives me a common denominator. So now I have 2x, 2x, and that. And here I have a minus 1 over our common denominator here. Okay, now how do you show that a fraction is 0 or undefined? Because this is the derivative. A critical point is where this equals 0 or is undefined. Well, fraction 0 if the numerator is 0. So we set the top equal to 0 right here. Well, I don't like the square root. If we were to square at this point, we'd have to multiply 2 of these out and FOIL it and do all this stuff, and it gets ugly. So instead, we're going to add 1 to both sides. So that's why I end up with a 1 there, and that disappears. Now we can square both sides, and it's much prettier. So square on the left side, that becomes 4, that becomes x squared. Square rooting a square, they cancel out, and square of 1 is just 1. Now I am trying to solve for x. I need to get a 0 on this side. So to do that, first I distribute these. So that gives me 4x squared. And then 4x squared times x squared is minus 4x to the 4th. And I want everything on one side, so I subtract 1 from this. But I subtract 1 from this side, that's where that comes from. Now I'm going to rearrange this, put this first, that second, and that third. And I get that. But I'm still not happy because I don't like the negative in front. But I have an equation, so I can multiply both sides by negative 1. The right side 0, and the left side becomes plus minus plus, and that's what I have here. Now, this is where it gets crazy, and I don't think I've ever seen one of these like this on an AP test, where you have to factor a 4th degree polynomial. Other than if it's the difference of 2 squares, I may have seen that. So I need 2 sets of parentheses. That's where that comes from. And then let me use some colors here. That times that must equal the first term. So if you ask yourself, what 2 things multiply to get 4x to the 4th? 2x squared and 2x squared. That matches. Now this times this must get you that. Well, here's a question. What 2 numbers multiply to get 1? Duh, 1 and 1. So that matches. Next, and I'll erase this. That times that and that times that gets me, and before I do that, I don't know that's negative. So that gives me 2x and 2x. But these two must combine to get minus 2x squared, sorry. These two must combine to get me my middle term, negative 4x squared. The only way that's going to happen if it's negative and negative, so therefore these must be minus. So that's how all that comes about. Let me erase all this stuff here. So that's how that factors to that. Then, if this equals 0, it doesn't matter what that is, the whole thing equals 0. So I set the first one equals 0, and that one's the same thing, so I don't have to do it over again. Add 1 to both sides, that's why I get a 1 there. Divide both sides by 2, and that 2 disappears. I square root both sides, but when you square root, you get a plus or minus, and you have that answer. Now we're going to look at more stuff here. Back to this derivative. Here's our derivative. A critical point is when that derivative is 0 or does not exist. When does a fraction not exist? When the denominator is 0, you learned that's a no-no. So therefore the function doesn't exist at that point. So I set that equal to 0, the denominator. I square both sides. Then I add x squared to both sides. That's how I get that there. Then I square root both sides. I get plus or minus square root of 1, and I get those two values. But let's look at the original equation. The domain is -1 to 1. And a critical point has to be an interior point, can't be an endpoint. So -1 and 1 cannot be critical points. So therefore, that is eliminated from our critical points. Now you may think we have two critical points, plus and minus radical 1/2. But weird things happen sometimes when you square. I don't know if you remember, way back here we squared both sides. That can introduce extraneous roots, roots that actually don't work. And so if we take these two answers and we plug them in to our original derivative, I would say right here, you can try this. One of them works and one of them doesn't work. What ends up happening, so this is radical 1/2 and negative radical 1/2. When you plug in negative radical 1/2, it actually is not a solution. It's not part of the solution or where the derivative equals 0. Therefore, you don't consider that. So I should have eliminated the negative here, which I didn't. And I'm going to change this. So I shouldn't have looked at this case here, because that will not be a critical point. And so we have 3 critical points. I'm making a mess of things, aren't I? Actually, 1 critical point and 2 endpoints. So our endpoints of our graph are -1 and 1. So we're going to find the y value of our graph at those 2 points. We only had 1 critical point. I find the y value there. So whichever one has the biggest y value is the maximum and the smallest is the minimum. Well, if I plug -1 into my original equation, I get this. Some of you might be wondering where pi comes from. When you put a -1 here, the arc cosine is asking what angle has a cosine of -1, and you should know that's pi. And then when you plug in this, that's the same as 1 over radical 2 or radical 2 over 2. So when you're looking for the angle that has a cosine of 1 over radical 2, you should know that's 45-degree angle, which is pi over 4. And then the last one, 0. What angle has a cosine of 0? Whoa, not 0, 1. On drugs here, on 1. Pi over 4. Whoa, what am I doing? Plug a 1 here. What angle is the cosine of 1? 0. The cosine of 0 is 1. Woo! Okay, there we go. So the biggest one is the max, so 1 plus pi is the maximum value. The smallest one's the min, which is 1. What's this? This was just help me find the max and the min. Pi 3.14 plus 1 is about 4.14. And that's about 3/4 plus 1/2 is about 5/4. So that's a way I can compare the values of these roughly to know the max and min. So that's the end of this problem.